Fill in the boxes with the correct numbers according to the rules. In Lesson 1, we learned that observation means examining everything that influences an object without missing anything. In Lesson 2, we experienced two more properties of observation. First, observation allows us to divide an object into parts. Even if the whole looks big and unfamiliar, if we divide it and look at it, we can see what we already know. Second, observation does not end with just one try. As the deduction progresses, newly discovered facts are also included in the scope of observation. Do not give the answers directly. When the student is stuck, only ask, "Did you examine everything that influences that box?" Please maintain the format of stating a claim and a reason until the end of this lesson as well. Do not give the direction first before the student discovers it on their own. Waiting is the most important role of the teacher in this lesson.
Wow, it got so big. It's too complicated, I can't solve it.
It is true that it got bigger compared to the problem in Lesson 1. But is it also true that it got more complicated?
Of course, if it's big, it's complicated.
Is that so? Let's talk about Lego blocks for a moment. Do you think you can build this?
This is easy.
What about this?
This has so many parts and looks complicated, so it must be hard. See? It gets complicated because it got bigger.
I see. Then what about this?
Easy? I can build it super fast.
How about this one? Is it hard because it got bigger?
This is just a bunch of one-story buildings stacked together. It might take some time, but it's not hard.
Does it get complicated when it gets bigger?
Not always. When it just grows the same way, it doesn't get complicated.
Which of the two cases is this cross-sum problem?
If I divide it like this, it looks like a bunch of Lesson 1 problems stuck together.
Can you tell me a little more about what you mean by dividing it?
If I look at the whole thing at once, it feels big. But if I divide it into sections, each section is about the same size as Lesson 1. The sums are still just made of 2 numbers or 3 numbers.
Then, do you think you can solve this problem?
Yes. I think I can just divide it into 4 sections and solve it.
Shall we try?
Four only has one way, 1 plus 3.
You are looking at row 2.
I have to look at both the row sum and the column sum together. I think it's better to look at column 3 first, rather than column 2.
Why column 3?
Because 8 has 2 ways, 1 plus 2 plus 5 and 1 plus 3 plus 4. But 7 is only 1 plus 2 plus 4. 7 is a unique number combination.
Then, which box can you figure out by examining both the row 2 sum and the column 3 sum?
2, 3 is 1. Because 4 equals 1 plus 3 and 7 equals 1 plus 2 plus 4. And the only common number is 1.
Once 2, 3 is filled in, there are boxes you can figure out one after another, right?
2, 2 is 3. Because 4 equals 1 plus 3. And since we already know 2, 3 is 1, the remaining number is 3.
And next?
3, 3 is 2 or 4, but I am not sure.
What do you need to examine to figure out 3, 3?
I have to look at both the column sum and the row sum, that influence 3, 3. Looking at column 3, 3, 3 is 2 or 4, but looking at row 3, it cannot be 2.
Why is that?
If 3, 3 is 2, then 3, 2 is 3. There would be 2 3's in column 2. It is a duplicate.
You even examined 2, 2 to figure out 3, 3. How are they connected?
Because 2, 2 influences 3, 2, and 3, 2 influences 3, 3. So, 3, 3 is 4 and 3, 2 is 1.
Tell me your answer and explain why for the remaining 2 boxes too.
4, 3 is 2, because 7 equals 1 plus 2 plus 4. And since we already know 2, 3 is 1 and 3, 3 is 4, the remaining number is 2. 4, 2 is 4, because 8 minus 3 and 2, 2 and 1 and 3, 2 is 4. I will move down to the bottom section now. I see the small numbers 3 and 4. A box in both of these lines will have fewer possibilities.
Where is that place?
Where the 3 line and the 4 line meet. 7, 2.
Tell me your answer and explain why.
7, 2 is 1. Because 4 equals 1 plus 3 and 3 equals 1 plus 2. And the only common number is 1.
And next?
6, 2 is 2. Because 3 equals 1 plus 2. And 7, 2 is 1. 7, 3 is 3. Because 4 equals 1 plus 3. And 7, 2 is 1.
Keep going.
6, 3 is 4. Because 7 minus 3 equals 4. 6, 4 is 1. Because 7 equals 1 plus 2 plus 4. And since we already know 6, 2 is 2, and 6, 3 is 4, the remaining number is 1. It is going so smoothly.
You seem excited. What just happened?
If I find one number, it helps me find the next one. And that one helps me find another. Like dominoes.
What was the first box of those dominoes?
7, 2. It was the place where 2 unique number combinations met. Looking at the unique number combinations. There are 16, 17, 23, and 24.
Which boxes are influenced by them?
There is 3, 7 where the 24 line and the 17 line meet. And 5, 5 where the 23 line and the 16 line meet.
Which one should we do first?
3, 7. 24 equals 9 plus 8 plus 7, and 17 equals 9 plus 8. Huh? There are 2 common numbers, 9 and 8. I cannot figure it out yet.
What should we do?
I should look at 5, 5 first. 23 equals 9 plus 8 plus 6. And 16 equals 9 plus 7. And the only common number is 9. 5, 5 has to be exactly 9.
Are there any boxes you can figure out now that 5, 5 is filled in?
5, 4 is 7. Because 16 equals 9 plus 7. And 5, 5 is 9. And next. 4, 4 is 3. Because 11 minus the 7 and 5, 4. And 1 and 6, 4 is 3.
What is the next box you can figure out?
Since I know 4, 4, I can also figure out the box to its right. 4, 5 is 6. Because 15 minus 4, 2, and 3 is 6. I know 3, 5. It is 8. Because 23 equals 9 plus 8 plus 6. And the boxes for 9 and 6 are already filled in. So the only remaining number is 8.
Has the domino effect stopped now?
No. Now I can figure out 3, 7.
That box had 2 choices. How do you know it now?
When I did not know 3, 5, 3, 7 was 9 or 8. But now I know that 3, 5 is 8. If I put 8 in 3, 7, it becomes a duplicate. So I have to put 9.
The box that was stuck is figured out. What happened?
I figured out another box first, and that box became a clue. So there are fewer choices for the stuck box.
Now, knock down the remaining dominoes. Does it get complicated when it gets bigger? This is a question that challenges the judgment made as soon as seeing the problem. Distinguishing size from complexity and connecting the unfamiliar to what is already known is the beginning of observation. The box that was stuck is figured out. What happened? Another box was figured out first, and that box became a clue. Being stuck doesn't mean you are wrong. It is a sign that there are still things to examine. This is the moment the student learns this through experience,